The problem here with the book on the incline and the cup hanging over here. And they give you the mass of the book, they give you the mass of the cup. The coefficients of friction are 0.5 and 0.2 for everybody, and this angle here is 20 degrees for everybody. So they tell you the velocity that the book is moving up the incline, so that's v naught. They give you that, and they ask you how far is it going to move up the incline. Well, they're talking about this kinematics equation, v squared equals v naught squared plus 2a x minus x naught, where they gave you v naught. V is 0, and what they're asking you for is x minus x naught, right? So obviously, in order to be able to do this, we have to find A. So we're going to be finding A from the free body diagrams. So for the book up on the incline, we have mg pointing down, but I'm going to call it m sub bg because that's the mass of the book. We have normal force going this way. We have tension from that string pulling downward, and we have friction. Friction goes down the hill because the book is going up the hill. So there's the friction. For the cup, we just have mg, which for the cup is m sub cg, and the normal force, not the normal force, this is tension pointing upward. Same tension as that one. And that right there is supposed to be g. Okay, so those are our two free body diagrams. Now we want to bring in the axes so that we can do some equations. So here I'm going to put my y-axis along the normal force and the x-axis perpendicular to that in the direction of the motion, like that. Okay, so that's my x-axis. I see 1, 2, 3 vectors flat on axes, but the one vector that's not on an axis is the mg vector here. And I see that that is not this angle 20 up here, it's this angle way up here, that angle. So that angle there is 70. So I'm going to write my x equation. So if you tip your head to the side, you see that these two vectors that are flat on the x-axis are pointing to the left. So those are negative, minus t minus f. And then the x component of the slantways vector is also negative. So that's going to be minus m sub b g cosine 70. And those all have to add up to what's happening. And what's happening is that it's moving to the right but slowing down. So that's a negative ma. And it's m sub ba because this is the book. Then for the y equation, we have the normal force is flat on the y-axis and it's going up, so that's positive. And then we have the y component of the mg vectors, and it's going downward this direction. So that's minus m sub b g sine 70. It's sine because that's the y-axis. And that has to be equal to 0 because it's not moving at all in the y direction. Now, we have friction, and it is moving, so friction is equal to mu sub k times the normal force. Now over here on the cup, we just have tension minus m sub cg is going to be equal to, now the cup is going to go up, so this is m sub ca, positive, because it's going to go up. So now I just need to put all of these equations together to find the acceleration. So from these two equations working together, I find out that the friction is equal to mu, I'm just going to remember that it's mu sub k, I'm not going to write that anymore, mu m sub b g sine 70. From this equation, I see the tension is equal to m sub cg plus m sub c a. And I'm going to stick both of those into this equation here. So I have minus tension, m sub cg plus m sub c a minus mu m sub bg sine 70 minus m sub b g cosine 70 equals minus m sub b a. So there I have an equation I can solve for the acceleration. If I do some algebra, this should come out acceleration equals m sub c plus m sub b cosine 70 plus mu m sub b sine 70, all of this times g divided by m sub b plus m sub c.